Friedel-Crafts acylation reaction can be given by acid halide that is RCOCl. It can be given by acid that is RCOOH, and it can also be given by acid anhydride. So let us discuss Friedel-Crafts acylation with acid and acid anhydride. For example, if I have this problem, and a strong acid H3PO4, what will be the major product in this reaction? So first you have to generate a selenium ion that is electrophile, H3PO4 will act as acid, and weak acid CH3COH will act as base. So it will take H plus. So we will have CH3COOH2 plus H2PO4 minus. Now the next step, we can lose one molecule of water to generate a selenium ion. And this acylinium ion is resonance stabilized. So acylinium ion is resonance stabilized and very stable. So for this structure, octet of each atom is complete. So this resonating structure, octet of each atom is complete. So very stable. So now this acylinium ion will react with benzene, and this is simple electrophilic aromatic substitution. A hydrogen will be replaced by CH3CO group. So this reaction is simple electrophilic aromatic substitution. So what will be the product for this reaction? So we have benzene, and this is reacted with anhydride, and the reagent is AlCl3. So what will be the major product? And this time this is again Friedel-Crafts acylation. Only thing is reagent is anhydride. So in the first step we will have Lewis acid base reaction. AlCl3 will act as Lewis acid. So this is Lewis acid, and anhydride will act as Lewis base. So we can give one lone pair of electron and the product is a complex oxygen will have plus formal charge and aluminum will have negative formal charge. Now this bond becomes weak, so next step we can break this bond to generate CH3CO plus, that is a selenium ion, and we will have inorganic product. Now we have generated a selenium ion. This will react with benzene ring, and this is simply Friedel acylation. So this is electrophilic aromatic substitution. So we have to replace one hydrogen with CH3CO group. Now let us try this problem. What will be the major product in this reaction? And this reaction is same as the first reaction, that is acid reacting with H3PO4 generates acylinium ion. This time acid itself in the same molecule. So first we will generate acylinium ion, and in the next step benzene ring will attack. Finally we can lose H plus to gain aromaticity. So this is the final product. This is intramolecular Friedel acylation with acid. So we have acid group here, and this is an intramolecular reaction because reaction is happening inside the same molecule. So this is a case of intramolecular Friedel acylation with acid. So with acid group. So when this compound is treated with H plus, initially gives A, and when A is heated, this gives B, and it is given A is an alcohol, so it has a OH group, and B as an alkene, that is it has a double bond. So let us explain the formation of product. So now in the first step, we have H plus. So catalyst is given, the medium is acidic. Now this lone pair will act as a Lewis base, so it will take H plus. At the same time we can open this bond to generate an electrophile. So we will have this electrophile. Now this electrophile will be attacked by the benzene ring. So this benzene ring will act as a nucleophile, and finally loss of H plus it will generate. So I am writing the final step after losing H plus to gain aromaticity. So we will have this as the product. Now this carbon and this carbon will be connected, and this will have a OH group and it will have a CH3 group. So this is product A, and it is also given A is a alcohol. So this is alcohol. Now the next step is dehydration. Basically it should be heated in the presence of acid. So next step is dehydration of alcohol. So if I do dehydration of alcohol, that is I have to lose H plus and OH minus, will generate a double bond. So second step, that is A to B, is simply dehydration of alcohol. So we will have a double bond here. So this is the final product we will have in this case, that is B. And B is an alkene because it has a double bond. Now let us try this problem. So we have benzene ring, and this is reacting with an anhydride, and this is a cyclic anhydride. This gives product A in the presence of AlCl3. So let us derive a structure of A. Once again we have to generate a selenium ion. So we have AlCl3, it will act as a Lewis acid. So this goes here, and at the same time we can break this bond to generate a selenium ion. Now this acylinium ion will react with benzene to give electrophilic aromatic substitution this will be the product. If this is acidified, finally we will have acid as a functional group attached here.